In this module, we'll be covering the web filtering feature. These are some of the topics that will be covered by this module. We'll be looking at describing and configuring web filtering. This includes knowing and understanding the options for filtering. We'll also learn about some of the different methods and advanced features provided by the filtering options. Finally, we will take a look at the web filter profiles and how to apply them. We're now going to look at the web filtering feature. This includes content inspection, URL filter lists, and FortiGuard filtering. What is web filtering? Simply put, it is the act of controlling the websites that a user has access to. This can be done for many reasons, such as to block inappropriate content, reduce network congestion, preserve employee productivity, and the list goes on. Web filtering can be used as a way of preserving employee productivity, preventing bandwidth misuse, and reducing exposure to threats. The list of potential benefits, if used correctly, is quite large. There are three different options that can be used with web filtering. There is flow-based, proxy-based, and DNS-based web filtering. We'll first talk about the proxy-based solution. As the name implies, proxy-based filtering makes use of a transparent proxy in order to intercept communications between the client and server. It is capable of inspecting the full URL of the website in order to determine if access is allowed or not. It is also the only method of web filtering that allows for customizable block pages to be displayed in the user's browsers. While this provides extra security, it obviously also comes at a cost. This is the most CPU and memory intensive option out of the three. This is because the Fortigate unit needs to intercept and proxy the transmissions. It is also the slowest when you compare it to the other two options. Proxy-based is the default setting in a web profile. While this method is the most resource intensive, it is also the most accurate. You can see the advanced section. There are a lot of options available on how to inspect and look at the websites that users visit. Another option for web filtering is to use flow-based mode. This is a non-proxy solution that uses the intrusion protection engine to examine the data as a stream. The advantage here is that data is not cached, and there are not the same delays a proxy imposes. The IPS engine is designed to handle a great deal of traffic, so your maximum data throughput is much higher. Like proxy-based, it also inspects the full URL in order to determine access. While there are some great advantages, there are also some limitations to this. First off, web filter overrides are not possible. Even if an active override is in place, it will have no effect. You are limited to using URL filtering, FortiGuard filtering, and rating overrides in the advanced options of the web filter profile. The advanced options section is much smaller. You can't do things like restrict cookies, Java applets, or ActiveX. It is simple enough to switch the method of operation. There is the option to select the mode of operation in the top section of the web filter profile. You can also see the advanced options section doesn't have nearly as many options for filtering and inspection. This is the major limitation of flow-based inspection. Since it's not a proxy, it doesn't understand the traffic with the same level of details. Lastly, we have another option for web filtering called DNS-Based Filtering. As the name implies, the DNS query is used to determine where the user is going. The query gets redirected to the FortiGuard SDNS servers in order to determine a category. Since it is working on the DNS level and not proxying or parsing HTML traffic, it is very lightweight on both memory and CPU resources. When accessing a website by IP address, the FortiGuard service resolves the address. Therefore, a website that is normally blocked by URL is also blocked by the IP address. Finally, you don't need any type of SSL inspection turned on. HTTP and HTTPS protocols both begin exactly the same way, that is, with a DNS lookup. Since neither protocol is actually being inspected in any way, you do not need to concern yourself with SSL communications of any kind. SSL is a topic covered in the 301 course. Now for some of the disadvantages. Since it operates on the DNS lookup, the URLs are not contained, only the host name. So your filtering is not as granular as the other two methods. Because of this, none of the advanced options in the profile can apply since they all operate on the URL or information on the website. You can only make use of a web URL filter list and FortiGuard category filtering, and only on the host name. Also, you cannot get individualized block pages. You can either have the DNS response give a domain not found in the browser, or supply a portal and build a generic block page that these queries can be redirected to. Once again, switching the mode is not difficult. DNS-based filtering is suitable if you do not need granular control for web filtering. Since this can only operate on host names and not full URLs, you do not get the level of accuracy that Flow or Proxy-Based provides. However, if you do not have the resources for this level of URL filtering but still require a solution, this provides a very low resource method of doing so. Flow-based is suitable for high traffic environments or situations where a proxy would be unsuitable. Proxy-based is best suited for high security environments or situations where users require a lot of feedback through block pages and/or high levels of individualization. It is the most accurate and versatile option. Let's take a look at the steps that go into visiting a website to see where the web filtering function takes effect. First, a DNS request gets sent out. When the response comes back, the Fortigate device checks the details, assuming you are using DNS filtering. This does not happen on the initial outbound request because there is no point in using up resources to check if a website needs to be blocked when it does not even exist. Assuming the site is valid, the request passes unaltered, otherwise the unit acts according to the configured settings. Now let's assume that DNS-based filtering is not being used and the DNS request has just occurred, or possibly the computer knows the IP address already and no DNS request is made. After the DNS request takes place, the three-way TCP handshake occurs. This is allowed without any interference regardless of the website because proxy and flow-based filtering haven't occurred yet. After this, the HTTP GET request is made. With flow-based or proxy-based, nothing will happen on the FortiGate device until the HTTP 200 response is received. The reason is exactly the same. There is no point in spending resources to block a website that does not exist. If the website responds with a 300 redirect, the Fortigate will do nothing until it receives a 200 response. It will then act upon that specific URL, not the one that was typed in. There are advanced filtering options to have the unit rate redirects as well, but this is the default behavior. Just a quick highlight of the differences in the modes of operation. Proxy-based filtering is very secure. HTTP, HTTPS understanding is built into the proxy, so you would need to fool the proxy first in order to get invalid commands through. It is also the slowest method since traffic is cached, which causes delays. Flow-based has a much higher throughput, and since it does not run through a proxy, it does not incur the same delay in the traffic that a proxy would. However, it's not as secure since IPS is a pattern match engine. While it is programmed with the rules of HTTP, it does not have any understanding. DNS-based is very lightweight for both memory and CPU, but isn't very granular. It can only act on the host name, not the entire URL, since it is based on the DNS lookup. Also, since it takes effect before the website is even contacted, you will not be able to use any of the advanced filter options, just URL filtering and FortiGuard categories. Web content filtering is exactly like banned word detection in an email. Bad or unwanted words are given a weight value, and then all detections of these words are added together for a total which is compared to the threshold value. If the threshold is exceeded, you arrive at an action. It is important to mention that none of the web filter queries or actions are performed until the website actually responds. The reason for this is simple. There is no point wasting time blocking a page if the website is down or not responding. If you enable this feature, you should do so with caution. If the site is blocked, then you cannot see the website in order to confirm where the detection is happening. Also, the feature looks at both visible and non-visible information. Just because the site contains a bad word as a meta tag and is something the user won't see unless they view the source, it will still be treated exactly the same by the Fortigate unit. Once you decide on the method of inspection and take into account the limitations of that method, it comes down to the actual URL the user is visiting and how you want to control access to the web content. There are 4 possible actions for a URL filter: allow, don't block the site and do not make a log entry; block, block and make a log entry; monitor, allow the site and monitor it with a log entry. It is important to note an exempt match stops all further checking, including AV scanning for the current HTTP session, which can affect multiple URLs. Enforcing safe search can be done for Google, Bing, and Yahoo. Safe search is an option that some search engines have in order to apply their filters to the search results that are displayed. This way, even if safe search is disabled in the browser, the Fortigate unit will make sure the query is subject to whatever settings the service decides. All the Fortigate unit can do is ensure that it is enabled. It cannot dictate the behavior of this, as this task is up to the search engine providers. It works by examining the URL and looking for the safe search string when you submit a search. If it is not there, the Fortigate unit will modify the URL to include it. YouTube EDU filtering is also available. This is a service offered by YouTube to educational institutions. When you create a special EDU account, YouTube provides you with an identifier. Unlike normal safe search, this does not append the URL, but adds an HTTP header into the packet. This identifies your school to YouTube when people visit. Within your YouTube EDU account, you can configure the filters and settings in order to limit video access within your school. When a user visits a website, you can use the FortiGuard live service to find out the category for the URL and allow or block access by category. This is a great way to perform bulk URL filtering without having to individually define each website. There are also different options available here than if you use a URL filter list. FortiGuard is a live service from Fortinet where websites are examined and categorized by both automatic and manual methods. You can find a description for each of the categories and what we consider to be part of that category on the FortiGuard website. FortiGuard ratings are split into categories. Within each category are subcategories. You can block subcategories individually or block a whole category with all its subcategories included. You can find the full list along with an explanation of what these categories actually mean on our FortiGuard website. The Fortigate unit can maintain a list of recent website rating responses in memory, so if the URL is one that the device already knows about, it will not have to send back a rating request. 2 ports are available for the unit to query FortiGuard with: port 53 and port 8888. Port 53 is the default since this is also the port number used for DNS, which is almost guaranteed to be open. However, any kind of inspection will reveal that this traffic is not DNS and prevent the service from working. In this case, you can switch to the alternate port 8888, but this port is not guaranteed to be open in all networks, so you will need to check this before setting this up. Since caching does consume memory, it should only be used if there is sufficient memory available on the FortiGate unit for this purpose. It's important to point out that FortiGuard is a live service. If the unit cannot make a connection to the FortiGuard network, all related options will stop functioning. If your contract expires, you have a 7-day grace period before FortiGuard will stop working. Another option is to restrict the amount of access users have by limiting the time they spend on websites based on the categorization. This is done with the quota option. This feature can be tricky to configure properly with larger websites. Most large websites store data in multiple locations, so the category of the site actually switches around a lot. Be sure to map out a website that you are not familiar with. The FortiGate unit can gauge how much time is spent on a website based on the time between URL lookups to a different category. A single quota can be configured to apply to multiple categories. For example, if you had a 5-minute quota that applied to both games and news websites, 2 minutes spent on a news site would leave you with 3 minutes for games. Quotas cannot redirect you once the website is loaded. For example, if you had 45 seconds left on your quota and you visited a website, it would likely finish loading before 45 seconds was done. You could then spend 20 minutes browsing the information you received. You could not get blocked or notified until the next attempt to access another one of these websites. The reason for this is that the connection to the website does not stay open. Once you receive the information, the connection is closed. Just like spam filtering, there is the possibility for errors or a scenario where you simply do not agree with the rating a site has been given. In this case, you can use the web portal to contact the FortiGuard filtering team and submit a website for a new rating, or to get it rated if it is not already in the database. At times, there may be cases where you do not agree with a rating provided for a website and the FortiGuard team does not agree with your reclassification request, if the admin has even submitted one. Other times, you may want to allow access to a website, but do not want to allow the entire subcategory. For cases like these, you can use rating overrides. This allows you to change the rating for a given website. It provides a way of overriding the Fortinet website category system when required. The action applied to the website will be whatever is configured for the category it is assigned in the rating override. These overrides are local and do not get submitted to the FortiGuard team. You cannot use wildcard or regular expressions. Only host names like google.com or www.google.com and not www.google.com/index.html because it is a URL. You also have the option of using local subcategories. This can be used for a number of different reasons, such as changing the text on the block page that a user sees, or it can also be used as a way to change ratings on a website to allow access. When you configure a rating override, you must set the category to custom category. After this is done, you will have the ability to assign the website to an existing custom category or create a new one. While you can create a custom subcategory from the GUI, if you want to delete or rename it, you will only be able to do so from the CLI. Be careful that you do not make any spelling errors or create these rating overrides unnecessarily. In order to change the FortiGuard action, right-click on the GUI to display a menu that looks like this. A worn action presents the user with a web page that looks like this one. The idea is that while these websites are allowed, the user now knows that they are being monitored. They will not be able to access the website unless they click Proceed. Another option for restricting access is to use authentication. The rating lookup happens normally and the action shows Authenticate. When you set the authentication action, you get asked which groups are allowed and what the authentication interval is. The interval sets how much time can go by before the user is prompted and needs to authenticate again in order to continue accessing that category. The user is then presented with an authentication page and told to enter their user information. This is then verified against who has been allowed access on the FortiGate's configuration. If all of these checks are successful, the website is displayed, otherwise access is denied. Here's a look at the web filter profile. At the top, you can enable FortiGuard and assign the actions to the various website categories. Like all the UTM security profiles, it is enabled through the Firewall policy. If you scroll towards the bottom, you will find the more advanced options that can be enabled, like Safe Search and HTTPS scanning. Once you have enabled and saved the settings you require, you will need to apply the profile to your Firewall policy to activate the options. There are several different components to web filtering, and when enabled, the inspection order follows the following steps: the local URL filter, FortiGuard category filter, web content, and finally the advanced filter options in the profile, such as Safe Search. Just like spam filtering, all the enabled checks are performed until an action is decided on block or allow. If there are no explicit match, then access is allowed to the site. The following is an example of the logs that are generated as a result of applying a web filter profile to the UTM setting on a policy. In this web filter profile, the social networking subcategory is being monitored. Just as with URL filtering, allow will not create a log entry, but all other settings will. Monitor will allow the site and log the traffic. When a user browses to a website like Facebook, we should see an entry in the logs under Security Log Web Filter. In the log entries, we can view details such as what policy the traffic was subjected to, what profile type, and profile name that triggered, and the URL that was accessed. We can also view the raw log data by selecting the Download Raw Log button in the top right. When we open the downloaded file, we are presented with the information in a syslog format. Now it's time for the labs. In this lab, we will be working with web filtering. Exercise 1 will make use of the FortiGuard category filtering. In this module, we'll cover the email filtering capabilities of the Fortigate. We'll set the groundwork by covering some basics about email, then we'll go over how to best leverage your deployment strategies. We'll cover email filtering options and the various actions the device can take. Then we'll talk about the order of filtering operations, and we'll briefly cover email filtering and scanning combined. We'll also cover how to submit false positives to our FortiGuard network. We'll finish with the configuration and enabling of email filtering and how to read the log messages. By the end of this module, you should understand the different email filtering options you can make use of on a Fortigate. You should be able to configure banned words as well as the black-white list options. You should be able to create firewall policies that have properly applied email filter profiles and know the difference between the different protocol options. We'll begin by covering a few abbreviations and terminology that are commonly used when talking about email. First, there's SMTP, Simple Mail Transfer Protocol. This is the original foundation of email. ESMTP is for Extended SMTP and simply expands the number of available commands. This is the most common method used to move email around the internet today. POP stands for Post Office Protocol and IMAP stands for Internet Message Access Protocol. Those are the two most commonly used mechanisms for accessing your email. MTA stands for Mail Transfer Agent. This is often referred to as the mail server. MAA stands for Mail Access Agent. This is on the user end and handles authentication and retrieval of emails. MUA is Mail User Agent. This is software like Thunderbird. MX record is a mail exchange record. It's like an address record in DNS, but specifically formatted for the purposes of email. A mail relay is an intermediate mail server, something in between the client and destination. Finally, Open Relay is when a mail server is configured with no restrictions on destination emails. SMTP is the protocol that email was built on and moves around with. It was a protocol designed to move a message from one location to another without knowing anything about the destination. It's a clear text, best effort protocol. This means that, as far as the protocol is concerned, there's almost nothing that is required in order for an email to be sent. You simply need a destination, everything else is optional. Now, most mail servers are set up to need more than that, but we'll be talking about the protocol here. There are 4 kinds of responses with SMTP. 200 numbers indicate a success, 300s indicate an incomplete command, like authenticating, 400s are temporary errors that could wind up correcting themselves, and 500 are permanent errors that require human intervention to fix. There is also SMTPS, which is SMTP wrapped up in encryption and operating on port 465 by default. An MX record is what you can use in order to resolve an email domain's destination. On the left, you see an MX record for google.com. On the right is an A record for the same domain from the same DNS server. As you can see, they're set up very differently. An address record only contains IP addresses. An MX record can contain names or IPs. If it's a name, then it gets resolved to an IP through a DNS query for the record of that host name. Also, each entry in the MX record has a preference which denotes an order they should be used in from lowest number to highest. The 2 other protocols involved with email are POP and IMAP. POP is a very basic protocol that really only lets you check your inbox by downloading and/or deleting emails. There's no functionality beyond that. IMAP is much more robust. It allows you to have multiple folders on that server. IMAP was designed to deal with many of the shortcomings of POP when accessing your email from multiple locations. Both of them have secure versions that operate on separate ports and encapsulates a standard protocol with an SSL. Let's walk through a fairly typical example. A user with the email address a@example1.org writes an email in Thunderbird to their friend b@example3.org. Thunderbird is set up to use post.example1.org as its server, so the email is sent there using SMTP. POP and IMAP are only used to check email. Post.example1.org is an MTA, a mail server. To forward the email to the destination, it must perform a DNS lookup for the MX record of the domain example3.com. The MX record comes back with two options for delivering the email relay.example2.net and mail.example3.net. Relay has a lower priority of 50. We'll assume this is a properly configured mail server, so it does an address lookup for the server with the lowest priority, relay.example2.net, opens up a TCP connection, and sends the email off using SMTP or SMTPS. Relay.example2.net does not directly host the email domain example3.com, so it does the same thing that post.example1.org did and does an MX lookup for that domain and gets the exact same results. We'll assume that relay.example2.net is set up properly and knows what its name is, so it ignores the entry and elects to send the email to the next server in the list, which is mail.example3.com. Finally, the end user connects to their mailbox, authenticates, and retrieves the email message using whatever email client they happen to be using. There are two actions available for email that is considered spam. It can either be tagged or discarded. Tagging simply flags the email as spam in some fashion that is detectable, so you can set up a filter on the mail server or the client software in order to perform an action on the email. This can include deleting it or putting it into your junk mail folder. Discard sends a 500-based SMTP message to the sending mail server telling them the email was refused. Discard is only available for SMTP, but the unit is capable of tagging emails on POP and IMAP as well. Email filtering is the technical term used for spam filtering. The Fortigate unit uses this to detect unwanted emails. The actual definition of spam is unsolicited bulk email. Which methods for detecting spam are supported by a Fortigate unit? Primarily, there's the FortiGuard inspection, which is a live connection spam filtering service that checks different aspects of the email. There are also some DNS related and other checks that can be turned on. After that, you have manually configured options like banned words and black whitelists. FortiGuard's primary inspection method is its FortiGuard IP list. FortiGuard will check the IP of the connecting mail server to see if it's blacklisted. The IP is queried, and if it is on the list, the email is considered spam. A score of 1 is a permanent value that will not change. You'll need to work with Fortinet's anti-spam team to get it unlisted. The score needs to be 3 or less for the unit to consider it spam email. It's not uncommon for an email to include a website or URL. FortiGuard maintains a database of spamvertised URLs. The email is parsed, and all the URLs that it contains are sent back to FortiGuard. If any of them match something that is in the database, the email is considered spam. Emails within the body of the message are also queried with the same results. Now, this is not the same as web filtering. URLs are not submitted to a category check of any kind. They are checked against our spamvertised URL database. Something to keep in mind when you're doing any kind of inspection of email content is the language the email was sent in or the character set. An email filtering device will filter the contents of the email in accordance with the character set it was sent in. There is also a database of email hashes. The Fortigate unit will also break the email up and hash different sections of it. For example, MIMEs, attachments, etc. Those hash values are then checked to see if they are blacklisted. A hash can be more difficult to describe. This is a way of tracking aspects of the email that the unit would not otherwise be able to inspect. But since the Fortigate unit is not a mail server, there are many specialized functions that it will never be capable of doing. There is also a locally maintained black whitelist. IPs on this list can have an action of spam, clear, or reject. Spam instructs the Fortigate unit to use the spam action in the profile. Reject tells it to refuse delivery of the SMTP message, and clear is when you want to stop further inspection and simply allow the Fortigate unit to pass the mail through. This is usually because you trust the sender. You can also put email addresses and domains on a local black whitelist. The main difference is that IPs are processed much sooner in the list of spam checks than emails. The next check is the HELO DNS lookup. In order to send an email, most mail servers require that the remote side identifies themselves. This is done through a HELO EHLO command depending on if SMTP or ESMTP is being used. The Fortigate looks at what is said and tries to resolve that to an IP address. There is no comparison made to the sender's IP address. The return email DNS check is different from the HELO check in that it looks at a different portion of the email. Instead of looking at the HELO, it looks at the reply to field and makes sure that the domain specified there will resolve to an IP. Unlike the HELO check, which relies on SMTP communication, this check is also available on all protocols. The banned word check detects keywords that you manually configure within the email. Unlike the other spam checks, a detected banned word does not necessarily mean the email is considered spam. Each word has a weight value associated. The weight of the detections is added up at the end of the email, and if this value exceeds the threshold, the email is considered spam. If not, the email is not spam. This allows you to make some keywords that will not cause emails to be blocked if they are detected on their own, and others that will. Banned words are manually configured and should be maintained by your email administrator. A poor banned word selection will result in false positive detections. Emails all contain MIME headers which describe different aspects of the email, such as who sent it, the language, the subject, and other options as well. The Fortigate unit can inspect MIME headers to attempt to detect email as spam. The MIME header check rules can only be set up using the CLI. This is really an expert option and should not be employed by anyone without a solid understanding of email functionality. Since every email software hides MIME headers from the users unless you explicitly configure it otherwise, most users are not even aware that this part of the email exists. If you are filtering spam on non-visible information, this may irritate your users if these rules are set up improperly. There is also the option to use third-party DNS blacklists and Open Relay database services. Keep in mind that many of these services also have restrictions on their usage, even the ones that are free. This is something that you will need to find out more about if you intend to use any of these services. Also, since they are third-party services, Fortinet will not be able to assist very much if any issues with violations are found using these rules. Normally, the IP-based checks, such as the FortiGuard IP, will only look at the IP of the device that is actually connecting to deliver the email through the Fortigate. From the CLI, you can change the behavior so the device will walk through the received header and check the IP of every server the email passed through on its way. If your DNS is slow to respond, this can cause issues because each IP needs to be checked in turn. Most emails only have a few entries in the header, but can easily have 5 or more. Here's a look at the receive headers from an actual email that came into Fortinet. The entry at the bottom should be the original, and you can see it's very short. It doesn't contain anything about where the email came from. The second entry has a lot more information. Looking at the names, we can say that this is where Google connected to and delivered the email to Fortinet. It contains a lot more information with details about the sender, recipient, and event that the connection was encrypted because there is TLS information there. Spam filtering provides a step-by-step approach to scanning the email. An email passes through each filter until it finds an action of spam or clear. Once found, this action is taken and all further checking stops. If an email passes through this entire list and does not receive a definitive action, then the email is considered clean. Due to the behavior and limitations of the protocol, POP and IMAP have a slightly different filtering order and available options. Because of how the protocol behaves and the limitations of a firewall, some of the options available to SMTP are simply not an option for POP or IMAP. As you can see, the order is not the same as SMTP, and not all the checks are available. This is due to the nature of POP and IMAP protocols. With SMTP, you are intercepting the email as it is being sent between two mail servers. POP IMAP happens between a mail server and a client checking their email. The Fortigate can enable caching of FortiGuard responses. This is so that the Fortigate unit will remember the most recent queries it made. The unit will store recent results in memory until they either expire or are pushed out. Most of the time, spammers are persistent and will keep hitting your device over and over again. Therefore, if your Fortigate unit has enough memory available, it is recommended to enable caching. Many of the smaller units do not have a lot of extra memory, so if you start to run out of memory, this should be the first option you disable on your device. You can change the default settings in the CLI by going to Config, System, FortiGuard, and making adjustments. The FortiGuard spam detection options are a live service and require a connection to the FortiGuard network in order to operate. You can use the command diag spam filter FortiShield server in order to check the health of the connection. As with anything, spam filtering is not a guarantee. Therefore, there is always the chance of a false positive. Since FortiGuard is a live service, you need to be able to request a removal from it. This is done through the web portal on the FortiGuard website, just like any other spam filtering service. There are detailed instructions on what information needs to be sent to our anti-spam team in order to assist. There's also a tool for doing lookups to our anti-spam service. By default, the email filter security feature is disabled on the FortiGate device. To configure email filtering, you must first enable this feature in the GUI as shown here. Here's a look at the email filter profile. It's basically empty until you turn on spam filtering. Once you do, you get access to the various spam filtering options that are available for each of the protocols. SSL encryption is another aspect of email. Turning on inspection is fairly straightforward. SMTPS is a separate protocol from SMTP and operating on a different port. It's really just SMTP encapsulated using encryption. In order to be able to do any kind of content inspection on that sort of traffic, you will need to apply an SSL SSH inspection profile. ESMTP also contains a command called starttls, which is not supported on all mail servers. If this command is invoked and there's no SSL SSH profile in place, the FortiGate will simply stop doing inspection for that session since it can't read any more information without using CA certificates that would be in the SSL SSH inspection profile. A common setup is to have both virus scan and email filter profile on the same firewall policy. It's important to point out exactly how these two features work together. When the Fortigate looks at an email, the virus scan happens after the email filter checks. Emails that are whitelisted, marked as clear by a previous email check, do not bypass the virus scan. A whitelisted sender could still be infected. If a previous email filter check marked the email as spam, it will not bypass the virus scan unless the spam action is discarded. The reason is the same. Even if an email is considered spam, it could also contain a virus. When a virus is found, what happens next depends on the email being marked as spam even if a previous filter marked it as clear. What happens depends on the spam action. Tag results in the infection being removed and replaced with a text file that contains the AV block message. Discard results in the SMTP connection being blocked with a 500 response. By default, any email filter log entries will show up in the forward traffic log. The forward traffic log is designed to be a brief summary only. You can see information such as the action, the sender, and a recipient email address. In the Logging and Monitoring module, we discussed enabling the option Extended UTM Log in the CLI in order to get more detailed information. A log is still generated in the forward traffic log, but an additional, more detailed log entry is also created under Security Log Email Filter. Compared to the forward traffic log, more detailed information is given. You can see the name of the email filter profile that caused the detection, the subject of the email. If you add more columns or view the log in raw format, you'll find exactly what caused the email to be considered spam as well. The behavior is not enabled by default because creating more detailed logs requires more resources, so you can enable it as you deem it necessary. In a situation where there's multiple devices or software scanning your emails for spam, you want to make sure that only one device actually handles the routing of those emails. Let's say you have a Fortigate sitting in front of a Barracuda, for example. The email comes in and hits the Fortigate first. Chances are, the only thing a Fortigate can do that a Barracuda can't do would be the FortiGuard inspection. Then, regardless of if the Fortigate thinks the email is spam or not, it should get passed through. This is because spam filtering is not an exact science. The protocol itself is best effort, therefore any kind of filtering can only be as good as the protocol. In the case of a false positive, you want to be able to find that piece of email and release it to the intended recipient. For that reason, there should be as few places as possible. Since the Fortigate considers this spam, you can set up rules to throw the email away here. Just use tagging on the Fortigate and look for the string. Also apply any additional spam filtering that the Fortigate is not capable of doing. If the Fortigate or this device considers the email spam, then throw it away. Another thing to consider with email is the geography. Where does your business need to receive email from? A lot of spam can be avoided simply by limiting where you allow it to be received from. Most businesses don't receive emails from outside their country, so setting up firewall policies using geographic address objects to block access from some IPs can be considered beneficial. Also, using banned words on emails based on the sender's domain suffix can aid in this as well. You need to be careful with this so you don't cause problems for the domains that you're doing filtering for. Now it's time for the labs. We'll be working with email on SMTP since this is the most robust of the three email protocols. The first exercise will have you enabling and testing FortiGuard filtering.